Good scientific afternoon. Here today to support you with GCSE revision. And what we are focusing on today is our balancing of equations. Now, when it comes to balancing equations, our actual um, equations themselves generally range from 1 to 3, maybe sometimes even 1 to 4 marks per chemistry paper. Now, it does depend on what they are actually getting you to do on this paper, but in general, they will ask you to balance it out. And with balancing it, you will then be expected to sometimes add the state symbols and in other times just simply put the equation as it is. Uh, Afternoon, Fletcher. If you are a GCSE student, I highly recommend you get over to my YouTube now, as we are live on YouTube as well, and we are doing GCSE uh, support for balancing equations. So, when it comes to balancing equations, let's look at this first one. The actual compounds themselves cannot be changed because if we change them and change the numbers found in them, hey, SJ, a whole load of numbers. Hey, Archie. Um, when it comes to these things and it comes to balancing of an equation, if we edit the actual stuff, what we have is then a list of basically chemicals that aren't what we would want. Now, if we're not wanting the chemicals to change, which when balancing an equation we don't, this is what we would be looking at. So, on this first scenario, we've got carbon plus oxygen makes carbon dioxide. Now, when it comes to any kind of balancing equation, and if you are just joining us, get over to YouTube and you'll see exactly what I'm talking about. So, when we are looking at our balancing, what you can see here is we would draw a carbon and an oxygen on the left and a carbon and an oxygen on the right. Now, when we are looking at balancing such um, equations, what we would want to do is make sure what we have on the reactant side is the same as what we have on the product side. Now, this obviously is sometimes a back and forth motion. And when we're looking at such a thing, we would want to make sure um, we are only changing the amount of that compound we have. For example, if I had 5 apples on the left, I can't just suddenly spew more apples up in regards to the answer. I have to, whatever that's made, link on both sides. All right. So when we are balancing. On the left side, our reactant side, I've got one carbon and I've got 2 oxygens. And on my right side, I've got one carbon and I've got 2 oxygens. Now, when we're looking at the balancing of an equation, in this first situation, I am balanced on both sides because I've got the same amount on each. Now, what this does for us is it helps us kind of understand that sometimes we don't need to edit these things. And one of the first things I always say to any of my students is, do you have just one single atom of carbon in this whole scenario? Do you have just one single oxygen molecule? And the likelihood is you will have a whole range of these chemicals on there. Now, what that then does is it actually makes it so that you kind of think a bit more broad spectrum. And this is one of the biggest things that a lot of students struggle with, is thinking about their actual GCSE chemical on a larger scale. Now, when we look at a chemical on a larger scale and think that there's billions and billions of chemicals involved, then we start to really understand that when we're saying that carbon collides with oxygen, well, there's so much of it that it is definitely going to collide. And we talk about in chemistry and in physics the collision theory, which is where there has to be enough energy for them to collide, break any bonds that they might have, and then actually make the new bonds instead. Now, on this, if we clear that answer now, on this next question, what we have is a hydrogen molecule, so H2, and we would add that to our oxygen molecule as well. So with this, and for anyone that is able to donate or anything like this, any of the gifts, that would be fantastic. All proceeds made during these videos all actually go towards paying for equipment that I will be using to pay for schools. We have a GoFundMe page for MC Science as well, which can be found on our website or in next to the bio on most of our pages as well. Now, when we're looking at our next one, we have a hydrogen and an oxygen molecule. And as you can see here, we have then it making water. Now, one of the easiest things where people make a mistake here is when we talk about, thank you, James M115, for the rose, much appreciated. And thank you again. When we're looking at our hydrogen and our oxygen molecules, hey Alfie, our actual hydrogen, let's change ourselves over to the keyboard a minute. What we would have is we've got the hydrogen on the left and we've got the hydrogen on the right. Of course, we've got it on the left and on the left. And on the left side of our equation, we've got two hydrogens and we've got two oxygens. And on the right side, our product side, we've got two hydrogen and we've only got one oxygen. Now, a lot of people just then kind of assume that, well, if I put a 2 after the oxygen, like so, well, that means that I've got two oxygen, two hydrogen on both sides. And if you are following along on our YouTube live right now, welcome. And when we actually look at this chemical, what this chemical actually is hydrogen peroxide. So H2O2 is hydrogen peroxide, the chemical that you would use to bleach your hair. And it isn't a chemical that you would want to drink like our H2O. Thank you for the fluffy penguin. Much appreciated. Remember, we are live on YouTube and we're live on TikTok at the same time, but those on TikTok cannot see what is on my screen at the minute with the balancing of an equation. So I have to change. So let's very quickly get rid of that because I would be incorrect by doing that. We have to change the quantity of the number of chemicals we have. So when we're looking at H2O, for me to have two oxygens in my product, I have to put a large 2 in front of my molecule, which is basically saying that it's 2 times the molecule. So I, instead of having 4 and I'll just change my mouse. Instead of having two hydrogen, I now have four. And instead of having one oxygen, I now have two because I've doubled everything. When it comes to balancing an equation, it's a multiplication, not a adding. And this is one of the things a lot of students struggle with is they'll say, oh, I need to add one more oxygen. You are technically correct, but we can't just add one more oxygen to a water molecule. We have to multiply it. We have to multiply the entire actual molecule itself. Now, what I would then have to do is on my reactant side, I would put a big 2 in front of my hydrogen molecule. Now, by putting a big 2 in front of the hydrogen molecule, what that allows me to do is put 2 times 2, which then creates 4 hydrogens on my reactant side and 4 hydrogens on my right. My oxygens then have 2 on each side as well. And what we then see is a balanced equation through the adding of these. And again, if you're wanting to follow along with what I'm currently looking at, move over to my YouTube channel right now, and you will be able to see live the balancing equations that I am currently going through. When we are then moving on to our next question, and again, I'm going to clear this just because we are currently working through this material and I will run out of room. So our next one, we are adding sodium to water. Now, when we add sodium to water, what we actually have is quite a vigorous reaction because whenever we add any of our alkali metals to water, it is vigorous. It's why we actually submerge our alkali metals in oil at all times because it won't react with the oil, but it will react with the oxygen and it will react with any moisture in the air as well, and it will basically tarnish and form a oxide layer on the outside of the metal. And if we cut it with a knife because it's super soft, we would end up with it going shiny and then really quickly, like in seconds, dulling back off because that's what alkali metals do. Now, as you can see here on the YouTube page, we have sodium and we have a water molecule. When we react the two together, we form sodium hydroxide and hydrogen gas. Now, just as a little extra bit, the way I would test that it was hydrogen gas being produced is that I would get a test tube upside down above the actual gas that's being produced. And because hydrogen is lighter than air, it will fill the test tube up, displacing any gases that are in there. And I would then get a lit splint, hold it against the opening, and it will form what we call the squeaky pop test. Now, the squeaky pop test is the test for hydrogen. And again, that is a question, especially on the foundation paper at GCSE, that they love to ask about. So, question number 3 here, I have sodium on the left. Oh my God, that is not an N. All right, let's start that again. That was terrible. We have sodium on the left. Oh, that was better than the first one. The A is way better than the N. Comment below if you think you're actually able to do better than the letters there that I'm using on my mouse pad. We have a hydrogen and we have an oxygen. And again, we've got the exact same on the other side. Because remember, when we are looking at conservation of any matter, what goes into a reaction always must come out on the other side. This isn't a situation where anything's lost. And one of the equations that they love to ask about GCSE as well is a gas is produced during a chemical reaction. What happens to the mass of the products? And most people will say, well, the mass of the product has got less, which isn't correct. The mass on the balance that you are observing is decreasing, but that's because part of the mass is changing over to a gas instead. So we're losing mass to the gas instead. So as you can see here on the left-hand side, I've got one sodium, I've got two hydrogens, and I've got one oxygen as well. And again, if you are a GCSE student, thank you, Luca. If you are a GCSE student and you're wanting support, please go over to my YouTube channel now and you'll be able to see what's going on. We also have then one sodium atom. We have one oxygen because I've got just the one there. And hydrogen wise, I've got one hydrogen here, but I've got two here in the hydrogen molecule, which then gives me three on the right side. Now, as I've stated, we cannot just add an extra hydrogen. I have to multiply the molecule itself. So when I'm looking here, because it's easier to get things to, hey, Finn Sheldon, because it is easier to get things to a even number because the hydrogen is only going in as a pair. We have to then look at multiplying the other side. So there's a big 2 in front of my sodium hydroxide molecule. And what that then does is that has now, and again, I'll change color. Finn, if you want any help with GCSE science, I am on YouTube Live at the minute as well, showing a load of balanced equations. Same with anyone else as well. So I now have two sodiums. And if you would like to comment in the box as well on how many hydrogens I now have or how many oxygens I have, that would be great for those on the YouTube Live. If you are rewatching this, pause it now because I am going to go over the answers. So we would then have 4 hydrogen and we have 2 oxygen now present because we've multiplied everything by 2, but I still have the 2 hydrogen there. Now, in this situation, I would then look at thank you very much for the gifts. I would then look at putting a big 2 in front of my water molecule on my reactant side, which changes that to a 4 and my oxygen to a 2. So they're now balanced. But my sodium still isn't balanced. So I have to then put a big 2 showing that 2 times my sodium molecule then creates 2 sodium as well. So what I have done is when I'm thinking about that lump of sodium that I'm throwing in there, there's billions and billions of sodium atoms involved. There's billions of water molecules as they collide together, they react, forming sodium hydroxide and hydrogen gas. With this, we are then going through to the next. Now, if anyone is on TikTok and you're able to support by doing any donations, that would be amazing. I have a GoFundMe account as well at the minute, which we are trying, MC Science as a company, we are trying to raise some funds to be able to start buying equipment, to be able to start doing more in local schools. So any donations that are made is much appreciated. And that goes the same if you are on YouTube or if you've transferred from any of the other accounts as well. Now, I'm going to wipe this out because we will move on to our next question. And there will be some chances now where I'm going to ask you all about what you would put. In fact, actually, I'm going to ask a couple of questions for if you are on the YouTube live. I'm from TikTok, Finn. Yes, I can see your name. Thanks, Finn. You have transferred over. So on this scenario, I've got one sodium on my left, and I'm going to have another good go at right in the end, to which actually was successful this time. And we've got two oxygens on the left side. And on our just in time, I like that, has just joined. Let's see if I can get the right side done as well. Yes. And we've got oxygen again. Now, in this situation, we are balancing equation. Now, we've got sodium reacting with oxygen to make sodium oxide. My question for you, if you can comment below, is what state do we normally find oxygen in? And whilst you answer that and comment below, I will continue with this question. So I have one sodium, two oxygen on my reactant side, and on my product side, I have two sodium and one oxygen. Now we are switching from one to the other, so therefore I've got to look at doubling things. Now, because there's two oxygen going in, I have to have two oxygen on the product side. So when I am looking at my two oxygen, I'd put a big 2 in front, which gives me 4 sodium because it's 2 times 2, and it gives me 2 times 1, giving me 2 oxygen. So my oxygens are now balanced. And again, if you are following on TikTok, if you go over to my YouTube, you will be able to see what we're actually talking about. Hey, Tyler, good to see you. And if there is anyone else that's commented on here so far and I've missed you off, I say hello to you all as well. It's just multiple screens trying to work here, and it's not always easy to monitor who's commented. I'm actually at UTC tomorrow morning for a assembly that I am actually promoting what I'm doing right now, so that then we can have any discussions and things like that about anything that will help you with your GCSE science revision. So on my reactant side now, is it all year groups? It's year 11 this time round, and then it'll be year 10 in one of the years at some point in the next couple of weeks. I'm just in the middle of talking with year 10 as well. So, head of year. So, oh, bless you. Well, I do miss teaching you all as well. It's definitely been a change for my system, but like I've said, I'm working at City College and working at a number of places as well now. So, when we are looking at the balancing of our equation, if I put a big 4 in front of my sodium here, I now have 4 times 1, which gives me 4 sodiums, and I have my 2 oxygens. So I am now again balanced, and I've balanced my equation accordingly. So when we are starting to envision the balancing of an equation, the key thing here is that we're not changing the actual chemical compounds themselves. What we are actually changing is the amount that we have through a process of timesing, or through a process of well, no, it's only, why am I saying or? It's only through a process of timesing. So as you can see here, we've got 4 times the sodium. We've got 2 times the sodium oxide as well. Let's go on to number 5. I am just wary of time. I am trying to stick to half an hour sessions for these videos so that the YouTube isn't too long. a recording. So this time we've got sodium chloride. I would tell you a joke about sodium, but I thought now I wouldn't bother. And with this sodium chloride, we obviously, can we see your tattoos? So tattoo wise, I have definitely gone up with the amount of science tattoos that I have got. I am still building this sleeve and it's getting more and more on that arm. Those at UTC will see it tomorrow if you're in and whatnot. Thank you, Tyler, much appreciated. So sodium is a highly reactive, aggressive metal. Chlorine is a toxic gas. When we bring the two together, what we end up with is sodium chloride, also known as table salt. Table salt obviously is edible, whereas you cannot eat sodium and you cannot eat chlorine. And this is one of the most fascinating things I find when it comes to chemistry, is how we are able to just merge chemicals together and they can either become highly dangerous or edible. And that's the beauty about chemistry. So on my left side, my reactant side, I have one sodium and I have two chlorine. And on my product side, I've got one sodium, one chlorine. Now, the sodium chloride as a whole obviously cannot be edited. I can't just put a 2 at the end of the NaCl because that's no longer sodium chloride, but I can double it because I can have 2 molecules of sodium chloride. And by putting that big 2 in front, what I'm now doing is stating that I've got 2 chlorine and I've got 2 sodium as well. And with my reactant side, I've got to put a big 2 in front of my sodium, which changes that to 2 as well. Now, I am going to leave it there for today's live. If you have donated or if you're able to donate to what I am doing, the support that I'm giving, that would be amazing. I am doing all of this free of charge. This is purely to support anyone that's needing GCSE support. This is a weekly session every Wednesday. And if people are wanting more sessions, I can look at increasing these sessions as well. But this has been session 4 or of these, and get over to YouTube and you can watch our previous sessions as well. And as always, like, share, comment below, and I'll see you all in the next video. Bye, everyone.